Number 24. A new spiral notebook contains 30 more sheets of paper than a new notebook. So, based on that statement right there, I'm going to write an equation. A new spiral notebook, so S will equal spiral notebooks, and M is going to equal memo notebooks. The spiral notebook contains 30 more sheets of paper than the memo notebook. So spiral equals 30 plus whatever's in the memo. The total number of sheets of paper in 3 new spiral notebooks, 3 new spiral, and 5 new memo is 110. So 3 spiral plus 5 memo equals 810 pages. Now all I've got to do is match the system of equations I wrote to the 4 offered to me in the problem. We can see that the way they've chosen to write their first equation is slightly different than mine. So let's transform this equation. Let's solve it so 30 is the only number on the right side. By subtracting m from both sides, I'll get negative m plus s equals 30. And then, to further match the way they've chosen to write things, I will use the commutative property to reorder, and I'll take my signs with me when I do that. S minus m equals 30, and then I'll rewrite the second equation. So, this is the system we could write to solve this equation. We're not being asked to solve, we're just being asked to write the equations. S minus m equals 30, check and check. Get rid of g and j. 3s plus 5m equals 810, check. And here they've reversed the values of the memo notebook and the spiral. So F is the correct answer. Which function is equivalent? So you've got a couple of options here. You can just go put them all into the calculator. That's a very slow approach, but it will work. You can FOIL all of these out and see what matches. Again, it's a very slow approach, but it will work. The most direct approach would be to use bottoms up and rewrite this as x squared minus 13x plus 30. This is a factoring question. I need 2 numbers that add together to equal negative 13, but multiply together to equal positive 30. And I think those are going to be 3 and 10. 3 times 10 is 30. And you could have tried others. 5 times 6 is 30, but you can't make 5 and 6 add to negative 13. 1 and 30 fail for the same reason. 2 and 15 are a possibility. 2 times 15 is 30. So maybe you could make those add to negative 13. But if we're going to multiply to positive 30, then we need both terms to be positive or both terms to be negative. So I don't think 2 and 15 is going to work, because one of those terms, the 15, would have to be positive, or the 15 would need to be negative, and the 2 would have to be positive in order to add to negative 13. So negative 3 and negative 10 are going to add to negative 13, but multiply to positive 30. So those are my 2 factors, x minus 3 and x minus 10. Now, finish using bottoms up. We multiplied by 6 at the beginning, so we'll divide each of these factors by 6, reduce the fraction. X minus 3 becomes x minus 1/2. X minus 10 over 6 becomes x minus 5 over 3. Bottoms up. 2x minus 1 times 3x minus 5. Wrong, wrong, and wrong makes F the only possible answer. At the very beginning, we maybe could have gotten rid of both A and D, because we know we're multiplying to something positive but adding to something negative, which rules out the possibility of mixed signs. (26) The average blue whale gains weight at a constant rate each day during the first 6 months of life. The relationship between the average blue whale's weight in tons, W, and its age in days, D, for the first 6 months of its life can be modeled with this linear function. Doesn't say linear, but I know it's linear because I've got a slope and a y-intercept. Based on this relationship, which statement is not true for the average blue whale? The average blue whale weighs 3 tons at birth. So, if A is age in days, or D is age in days, and W is weight in tons, the weight is going to depend on the number of days. So, weight equals 0.1 at birth, 0 days, plus 3. That's definitely going to make W equal 3 tons. So that one checks out. Which statement is not true for the average blue whale? So since this is true, I'm crossing it off. When the average blue whale is 5 days old, it weighs 20 tons. Okay, so what is the weight after 5 days of life? 5 times 0.1. That should mean W is equal to 0.5 plus 3. W equals 3.5. That one's very suspicious. The average blue whale gains 0.1 ton per day for the first 6 months of its life. That's an accurate description of the slope. So that one is true, and since it's true, we rule it out. When the average blue whale weighs 18 tons, it is 150 days old. So, if we plug in 18 for the weight in tons, equal to 0.1 times D plus 3. Subtract 3 from both sides to get 15 equals 0.1 times D. Divide both sides by 0.1. And we will get 150 for the number of days, which makes J check out. So we're not going to use J. This is the only statement that is not true, so G is the correct answer. The quadratic functions G and K are shown below. For what values of C will the graph of K be 9 units above the graph of G? That's fairly straightforward. This right here is telling you the y-intercept. That's exactly where the vertex is going to be. Both quadratics open upwards. They're both horizontally compressed or vertically stretched by a factor of 5. The only thing we want is a value of C that will make the graph of K be 9 units above the graph of G. How do I get 9 units above negative 12? I add 9 to it to get negative 3. So the value of C should be equal to negative 3. (28) A customer pays an annual membership of $85 to a neighborhood car wash. Each time he takes his car to the car wash, he pays only $7. The amount of money he spends at the car wash in 1 year in dollars can be found using this linear function. Slope 7, y-intercept, or an initial value, 85. What does x represent in this function? Well, what does y represent? The total amount of money he spends at the car wash in 1 year in dollars. Okay? So y is the amount of money. What does the amount of money depend on? The amount of money he spends depends probably on how many times he visits the car wash. There's his annual membership fee. each time he takes his car to the car wash, he pays only $7. So X is the number of times he takes his car to the car wash in 1 year. H. The cost of each time is $7. The number of months the customer has been a member is irrelevant, and the amount of money the customer spends each month at the car wash is also irrelevant. It's an annual membership fee. And we were talking about how much he spends in 1 year. This is a perfect example of a discrete linear function. Individual, separate, isolated points when compared to a problem from the previous video. This is discrete. Individual, separate points. This is continuous. Smooth, connected, unbroken line. The owner of a store buys large boxes of candy bars from a warehouse and repackages them to sell in smaller boxes in his store. The store owner packages 4 candy bars in each small box. Each large box contains 24 candy bars. Which graph represents the relationship between X, large boxes, and Y, small boxes? The owner buys... Okay, so for every one large box, which contains 24 candy bars, I should be able to repackage them into smaller boxes of 6. And A looks to be the correct answer. 1 large box is repackaged into 6 small boxes. 2 large boxes repackaged to 12, 3 to 18, 4 are repackaged to 24. A looks to be good. Here, 1 large box is repackaged only into 4. So they're trying to trick you by not doing any calculations and just pulling the number straight out of the problem. And then here they've reversed the numbering. So yeah, A is our correct answer to this problem. 30. This right here is a quadratic function. Point A is a vertical compression or horizontal stretch because the value of A is between 0 and 1. My variable is t, and that variable is being squared, so I know I'm dealing with a quadratic. L represents the length in feet of a pendulum, and t represents the period in seconds of the pendulum. Which value is closest to the period in seconds for a pendulum that is 30 feet long? So my length should equal 0.8 times t squared. Let's solve using the square root method. Divide both sides by 0.8. This is a quadratics. Solving quadratics. T squared equals, what is 30 divided by 0.8? That's definitely something we can go to the calculator for to get 37.5. And now let's take the square root of both sides. Get t equals positive or negative root 37.5. All our answers are positive, so we won't need to worry about the negative root. And we use a calculator again to take the square root of 37.5, keeping in mind that these two are obviously wrong because the square root of 36 is 6 and 37.5 is greater than 36. If I had to guess offhand, I'd say it's going to be J, and the calculator confirms T is approximately 6.1237 and a bunch more numbers. 6.1 J. Airline passengers pay $439 to fly to California. For this price,
customers may check 2 pieces of luggage. There is a fee of $25 for each additional piece of luggage a passenger wants to check. Which function can be used to find the amount in dollars a passenger has to pay to fly with P pieces of luggage where P is greater than or equal to 2?
They are limiting our domain here. They're telling us the inputs for this function, whatever this function may be, are only going to start from 2, and then they can get as much luggage as you want. So theoretically, in this problem, you could bring 100 pieces of luggage or 1,000 pieces of luggage. But we're going to have to account for this domain restriction right here.
Airliner pays $439 to fly to California.
So there's my $439 flat fee. Can't eliminate anything based on that one piece of information.
For this price, customers may check 2 pieces of luggage. So they get 2 for free, and then there's a $25 fee for each additional piece of luggage. That $25 fee is telling me I've got a linear equation, a rate of change. So I'm going to get rid of D and C because I should have something that looks like this. $25 per piece of luggage. But the first 2 pieces of luggage are free, so I need to start here. I need to start from 2. I need to account for the fact that the 2 first ones are free. Otherwise, when I plug in 1, I would already be paying $25 for the luggage. And I'm not supposed to be able to plug in 1. I'm supposed to start plugging in numbers at 2. So you plug in 2, and then you get the $0 here for the 2 bags. But plug in 3, and then 3 minus 2 is 1, so 1 extra bag is going to cost $25. Plug in 4. 4 minus 2 is 2. 2 times 25, so 2 extra bags will cost $25 twice, or $50. So this is a good domain application of reasonable domain to a linear equation. 32. There are 32 founding members of an organization. That's nifty. The function 3x squared plus 32, this is a quadratic function. It's got a y-intercept of 32. It has a vertical stretch or horizontal compression factor 3. Can be used to determine the number of members in the organization after X months. Y is the number of members. X is the number of months. Based on this information, which statement is true? The number of members in the organization increases by 9 members each month. I don't think that's true. The rate of change is not going to be constant because it's quadratic. So F is out. At the end of 16 months, there will be 288 members in the organization. Perfect. That's easy to test. Y equals 3 times 16 squared plus 32, and that is going to be way bigger than 288 members. 3 times 16 squared, I'll show you on the calculator. 3 times 16 squared plus 32 is 800 members. So 800 equals Y in this case, and that makes G almost certainly an untrue statement. So another untrue. We're looking for the statement that is true. So we've got F and G ruled out. The number of members in the organization increases by 3 members each month. Again, we are not dealing with a constant rate of change. At the end of 6 months, there will be 140 members in the organization. Good. That's easy to check. Y equals 3 times 6 squared plus 32. Watch how I put it in the calculator. Parentheses matter. 3 times 6 squared plus 32, and that should come out to be 140, which is exactly what they said. 140 members after 6 months. So Y equals 140. J is the correct answer. Scatter plot. There's definitely a linear relationship here. I can draw a trend line. Maybe my trend line is a tiny bit low. I've got an empty space right here. The scatter plot below shows a relationship between the number of baseballs used in 14 games and the number of pitches thrown in these games. So as pitches thrown increases, number of baseballs increase. Based on the scatter plot, what is the best prediction of the number of baseballs that will be used if 270 pitches are thrown? 275. So 270, 280, I'll go right to the middle. I'm going to head on up to my trend line, right around here somewhere. I'll put an extra big dot because it's the one I'm adding, and it could be a little bit above, a little bit below, hard to say. Draw over, and it looks like I'm going to be between 100 and 120. So my guess is 110 is the best answer, and 100 is the closest to my guess. 150 and 160 are clearly too high. That's over here at 300 some odd baseball pitches. 60 is way too low. That's down here at 250 or 260. It's surprising to me that this is an algebra question. A sixth grader could figure this out if the sixth grader knew how to read the graph. For us, we're going to have to remember that we have this R value, the correlation coefficient. We're almost certainly going to be asked about that because it's new to our TEKS. And you can discover that by you'll be using the stat, edit, doing a list, and doing a regression. In order to get the correlation coefficient on there, you go to mode and you set the stat diagnostics to on. And then you can go back and run your regression, and now the correlation coefficient is R. Now, that's not part of this problem, but you'll almost certainly be asked about it on the EOC. So it's good to know how to do that. Go to mode, press up once, and you can change your stat diagnostics to on by selecting, highlighting, pressing enter. (34) A plane can carry a maximum cargo of 160,000 pounds. A company used one of these planes to ship 2,000-pound containers. The total cargo weight is a function of the number of containers in the plane. What is the greatest value in the domain for this situation? In other words, how many 2,000-pound containers can I put onto a cargo plane that can carry 160,000 pounds? And that is a matter of simple division. Lop off the zeros. 16, 80 pounds. Again, barely even an algebra question. The only reason we can call it an algebra question is because we're using this terminology of domain. How many, and what is our domain composed of? The number of cargo containers, each weighing 2,000 pounds. What is the range composed of? The total weight that's on the plane. What is the value of x in the solution to the systems of equations? Okay, you've always got options when you're solving a system of equations. I've been told that y is equal to negative 6x plus 18. That's a y right there. So I'm going to use substitution, and I'm going to take this expression, negative 6x plus 18, and plug it in for y. 3x equals 2 times negative 6x plus 18. This was y, plus 14. Distribute, you get 3 equals negative 12x plus 36 plus 14. This should be a 3x. Then I would add 12x to both sides to get 15x equals 50. There we go. And now divide both sides by 15. 50 over 15, that will almost certainly reduce. Divide both by 5 and you get 10 over 3. X equals 10/3. The table represents some point on the graph of linear function g. I'm being told this is a linear function. I know my calculator
has the power to produce a linear equation given that table.
Why don't we go ahead and do that before even reading the question. Edit.
Let's put in the x values.
-4, -2, 2, 8, and then delete out. You can't have anything extra in there. Your domain must match your range. 13, 10.5, 5.5, -2.
Stat, calculation, linear regression. Why linear regression? Because they told me it's a linear function.
Alrighty, my slope is -1.25,
my y-intercept is b, and while I don't think I'm going to need it, my correlation coefficient is -1.
So let's write that down.
A is my slope, b is my y-intercept.
So this one should have an equation, -1.25x plus 8.
Now,
find the graph of g. Oh, the graph of g was translated down 10 units to create the graph of function h. Which statement comparing the graphs of g and h is true? So this is for g, and we can write the same for function h.
But if it was shifted down 10 units, my y-intercept of +8 now becomes a y-intercept of -2, because it was translated down 10 units to create h.
Alrighty. The x-intercept of g is 10 units to the right of the x-intercept of the graph of h. Possible. The graph of g is steeper than the graph of h. Not possible. The slope has not changed. The y-intercept of the graph of g is 10 units above the y-intercept of the graph of h. Almost certainly true. The graph of g is less steep than the graph of h.
Definitely not true. The slope has not changed if all we did was translate down 10 units.
Let's go to y equals, and just to be sure we can make
a distinction between f and h.
Let's put in both of our equations. -1.25x plus 8 and -1.25 minus 2.
Because our y-intercepts are so close to 0 and our slope is so reasonable, or rather our slope is
so close to 1,
the graph is going to be helpful. There's the first one, there's the second one. Now, I think h is the correct answer. Let's see if we can get rid of f.
The x-intercept, that's this one right here, and this is g, this is h, of the graph of g is 10 units to the right of the x-intercept of the graph of h. That seems true. Here's g. That does look to be 10 units to the right of h, but let's check the table. And we were counting by 5 in a previous problem, so I'm going to
change that back by going to second window for table set,
and I'm going to change my table delta back to 1, and now I'm counting by 1. Let's find the x-intercepts if we can. Where is the value of y equal to 0? So in fact, I should go to a whole number, and I should change my table set, my table delta, to 1.25.
Let's see if that helps. Because my slope
is 1.25. Look at the table. Okay, still missing out
on the 0 there, because I go from positive to negative without coming up with an exact 0 value.
So let's go to table set one more time and set it to
0.25. And it's going to take some more time, but I should be able to encounter the zeros here. We can see we're decreasing towards 0. Are we going to land on it? No, we're not. Okay, so this is one example where the table
isn't really being helpful. I don't want to keep guessing and checking. So we've got to choose between f and h. The y-intercept of the graph of G should be 10 units above the y-intercept of the graph of H, because G was translated down to create H. So how can we rule out F? The x-intercept of the graph of G is 10 units to the right of the x-intercept of the graph of H. So, how much distance is there between those 2 points? Is there 10 units? Let's see. You know what we can do?
Just to be extra sure. Second trace brings up the calculation menu. Let's find the 0. By pressing up and down, you'll see the cursor bounce between the two different curves. So let's start with this curve over here. It's a straight line, but we can call it a curve. Left bound, right bound, guess. Okay, the 0 happens at 6.4 for graph G. So I'll make a little note over here. The 0 is 6.4. Now, same strategy. Go to the calculations menu under second trace, and then find the 0. Press up or down to jump to the different curve. And you can see the cursor is now on the bottom line. And to find the 0, I'll go to the left of the x-intercept, the right of the x-intercept, and then the guess will be right there in between. And my 0, or my x-intercept, is negative 1.6. Now, is the difference between these two numbers 10? It almost certainly is not. Minus negative 1.6 would be plus. That's 0, carry 1. The difference between them is 8, and I think that difference arises from the fact that the slope is 1.25 and not 1. If the slope was 1, F would have been a viable answer, but it's not. So, it took some time, but we got access to another calculator strategy that's usually helpful on quadratics, but can also be helpful on linears. How do you locate an x-intercept? You put the equation into y equals, you go to the graph. If the table isn't helping out, you press second, trace, calculations, and you set a left bound and a right bound to find your 0. Okay, 37. What are the solutions to the equation? This is a quadratic. I'm going to use one strategy or another. Remember, before you can factor, you've got to set it equal to 0. So I'm going to subtract 18 from both sides equals 0. And what do you say we use a quadratic formula for this one? Even though our answers are whole numbers, which means we could find factors pretty easily. In fact, you know what? We could use a quadratic formula straight away. But look at the coefficients. 3, 15, and 18. The values of a, b, and c are all multiples of 3. So you can divide away the 3 at the very beginning and not have to use bottoms up. X squared plus 5x minus 6 equals 0. And now it gets real obvious. Adds to 5, multiplies to negative 6. That's x plus 6 times x minus 1. Because 6 times negative 1 is negative 6. 6 plus negative 1 is positive 5. Which means my zeros set the linear factor equal to 0. So x equals negative 6. And set the linear factor equal to 0. X equals 1. B is the correct answer. You know what else we could do that's sort of nifty? Again, let's go to y equals. And I'm going to put the left side of the equation into the graph, or into the y1. 3x squared plus 15x. And then I'm going to put the right side in. And go to the graph.
And initially, it might not look too helpful, but let's zoom out so we can include that 18. There's our quadratic, and there's 18. And now let's zoom box to look at those intersection points.
Again, let's use the calculation feature. Second calc. This time we want to know the intersections. First curve, press enter. Second curve, press enter. Then scroll over to the guess. It looks like it's about right here. Hey, look at that. X is -6.
Let's do it again for the other one. Intersection is option 5. First curve, enter. Second curve, enter. But now come over here and make the guess closer to this one. This is how you tell the calculator where to look. And look at that. When X is 1, Y is 18. There are multiple ways to go about solving these problems. If you understand how to use your technology, how to properly solve equations, you're going to be in great shape. We could even use the table. Where are the values? Oops, now let's change table set back to something useful. Table start 0, table set 1. Where are the values of y1 and y2 the same? When x is 1, we get 18 and 18. When x is -6, we get 18 and 18. Okay. A factory worker packed 12 boxes at a constant rate, took a 30-minute break, and then continued packing boxes at twice the rate before the break. So, after the break, he's working twice as fast than he was before the break. The worker then spent 1 hour cleaning the work area. Which graph shows the situation? Well, I'm going to get rid of H and J because this guy is breaking for a full hour. And then I'm going to get rid of G because in the problem, he works twice as fast after the break than he did before the break, which means I should be moving more quickly. The slope should be steeper after the break than it is before the break. The table represents some points on the graph of a linear function. Okay, let's go ahead. I've got a linear function, I've got a table. I always feel a lot better about linear functions or any table when I have an equation to go with it. So stat, edit, and enter in the x column for L1. The y column will be list 2. Stat calc for linear regression. Why linear? Because I'm told that it's a linear function. So my slope is -65, my y-intercept is 620. Y equals -65x plus 620. 620 is my initial value. -65 is my slope or my rate of change. Even if I don't need this equation, I have done myself no harm by creating it. The cost of dollars of buying X items that cost $245 each. So which situation can be modeled by this function? This one would not work because it is not taking into account a y-intercept of 620. The number of miles an airplane has traveled flying 555 miles per hour. That is definitely wrong because my slope is not 555. The remaining number of miles on a 620 trip after traveling 65 miles per hour for X hours. Remaining number of miles mean I should be taking away 65 every hour, beginning with 620. C is almost certainly correct. The amount owed on a $555 loan after paying $65 per month. This one has got the slope right, but the y-intercept is wrong.
Do this every time you get a table, linear or quadratic. Produce the equation that goes with it. Every time. Which inequality represents all the values of x when y is 46? Well, this should be super easy. We're going to simplify the right side. We're going to plug in 46 for y on the left side, and then we're going to solve, being very, very mindful of what happens with negative numbers and inequalities. 46 is less than or equal to negative 6 times x minus 18 minus 2. 46 is less than or equal to, distribute the negative 6. Distributing the negative 6 does not change the inequality sign, but it does change the negative 18 to a positive 18. Negative 6 times negative 18 will be 108. Take away 2. Continue to simplify the right side of the equation. Negative 6x plus 106. Subtract 106 from both sides. And I think that might be 70 or negative 70. 46 minus 106 is negative 60. Negative 6x. Now divide both sides by negative 6. Cancels, cancels. Because I divided by a negative, my inequality sign changes direction. Negative divided by negative is positive. My negative answer choice is out. My negative answer choice is out. And now you can see the trap that they have set. Even if you solve perfectly, if you do not flip the sign, change the direction of the inequality, when you multiply or divide both sides of your equation by a negative number, you're going to have a bad time. Oh, that's so wrong. If you do not look closely at your answer choices. See how easy that is to do? Let's rewrite it. Let's flip the direction. So 10 is on the right and x is on the left. I'm just going to rewrite it right next to it to be extra sure. Which one of those two match? So easy to make a mistake there, even if you do the right thing. Okay. What is the 0? So, what value of x can I plug in to produce a value of 0 on the right side? This is not r of 0. That is not what we are doing. We are doing 0 equals 8/3 x minus 16 and solving for x. Add 16 to both sides. Multiply both sides by 3, then divide both sides by 8. Multiply by the 3 to cancel out that denominator. 3 times 16 is 48. So I've got 48 equals 8x. Divide both sides by 8. X equals 48 over 8. And that reduces nicely to positive 6. My algebra looks good, but y equals. They've given us an equation. Let's take full advantage of our technology. The slope is 8/3. Never hurts to put that in parentheses, so I know that fraction lives together as the slope. Minus 16. Check out the graph. Now, it's all messed up because of the last problem we did, but don't worry. Use this zoom button. Go back to 6 for zoom standard. There's your standard window. Why can't we see the graph? Because our y-intercept is 16. So let's adjust the window. Let's be sure our y minimum is negative 20, and we can graph it. Now we can see the y-intercept, we can see the x-intercept. This is the 0 right here. It looks like 6. I have a calculator feature. Find the 0. Go to the left of the curve, left bound. Press enter, you see this mark appear. Go to the right of the 0. Press enter. You see a mark appear on the right side. Go to what looks like the 0 and press enter to make a guess. X equals 6. Don't like that? Try this. Go to the table. what value of x do I plug in to make y equal 0? 6. So many different ways to solve to get this correct. Thinking that you should plug 0 in for x would be the number one mistake you could do here. This is not. Well, what we've got here is r of x equals 0. This thing is equal to 0. That is fundamentally different than plugging in 0 for x. They did not tell us x equals 0. That's something completely different. That's the y-intercept. Okay, 42. The cost of parking in the garage at the airport is $16 per day. I'm going to write a short little equation right there. Cost equals 16 per day. A separate parking facility outside charges 25 less per day to park. 25% less. What would be the savings in dollars and cents of parking for 6 days in the facility outside the airport instead of the airport garage? We need an equation to go with this. What is 25% less of 16? Well, fortunately the numbers are easy, but 25% of 16 is 4. So it's going to be $4 less. Another way to do it, if we want 25%, then that means we're going to keep 75%. 75% of 16 is 12. So my two equations, 16D and C equals 12D for 6 days of parking. That's pretty easy to do. 16 times 6, 12 times 6. And solve, find the difference. 12 times 6 is 72. 16 times 6 is determinable, but we'll use the calculator. Subtract should be $24. Number 43. Two functions are given below. Both of them are linear functions. One has a slope of 5/8, the other 8/5. One a y-intercept, both a y-intercept of -3/11. I know that these two lines share a y-intercept, but they have a different slope. How does the graph of P compare to the graph of Q? The graph of P has a different y-intercept than the graph of Q. Well, that's definitely not right. The graph of P is less steep than the graph of Q. Possibly there has been a slope change. P is steeper. Possibly there has been a slope change. The graph of P is parallel. Definitely not. How do I know it's not parallel? The slopes are not the same. Now it's just a question of which of these two values is greater, 5/8 or 8/5. 8/5 is greater, so in my mind that makes it steeper. So then P should be less steep than Q.